To start our discussion about vectors, I've drawn 2 points on a standard XY coordinate system. The point A here sits at 1, 1, and the point B, 9, 7. Now, of course, we can draw a line between those 2 points, and there it is. And we can work out the gradient of such a line by plonking that point in there and looking at the rise, which in this case, we're looking at the y values here from 1 to 7. So this is a rise of 6, and the run. Now we look at the x values and we go from 1 to 9, and this is a run of 8. So remember those numbers, 6, 8, because what I'm about to do is get rid of the coordinate system and indeed the coordinates and just deal in what the line does on its journey from point A to a point B. So what have we got left? We've got a line joining the points A and B, and we know that the horizontal journey, if we took the journey from A to B, we'd have to do a horizontal journey of 8 and a vertical journey of 6. Well, without that coordinate system, we've actually drawn a vector. This is the vector AB. So vector AB is defined as 8 along and 6 up. Now we can write vector AB in several different ways. And here they are on the right-hand panel. Let me go through each of them. The first way is we can write the line's name in bold and it becomes a vector. Or we can put an arrow over the top of the name. We now have vector A rather than line A. Or we can describe its journey. The journey is from A to B, and we put an arrow over the top of our capital letters of our points A and B. And the other way is we can describe the vector as here, which is called a column vector. The x values are on the top and the y values are underneath. And we surround it by a bracket. This is not a fraction. We're just saying the vector AB, or A, is a journey of 8 along and 6 up. So let me put a grid back, as it will just help us count what the vector will be doing. Okay, let's move point A to here. We've now got a vector whose journey is described by the column vector here of 5, 6. Well, let's just check. We should be going along 5. 1, 2, 3, 4, 5, yes, and up 6. 1, 2, 3, 4, 5, 6. There we are. And I can move B around. A journey now of 2, 4. 1, 2, 1, 2, 3, 4. And of course I can make A higher than B and introduce negative numbers. The journey is always in the direction of the arrow, or indeed in the direction of this arrow, defining that the vector is a journey from A to B still. For our journey this time, A to B, we have to drop 1, 2, 3, 4, 5, 6. So here's our negative 6. And still go along a positive 4. 1, 2, 3, 4. Okay, let's do this one. Now you see, we're not doing a journey up the slope. Our vector is defined as a journey from A to B. So we have to come down this way. So we fall 1, 2, 3, 4, 5, 6. And we go backwards 1, 2, 3, 4, 5, 6. So our column vector is back 6, fall 6. So this is where lines and vectors slightly part company. We're told which direction to follow a line. So you can think of vectors as journeys rather than just lines written on a piece of paper. But of course, journeys add up. We don't just go in a straight line somewhere. We turn a corner, we go a bit here and a bit there, and eventually we'll end up at our destination. And that's exactly the same with vectors. So here I've introduced a second vector which joins on to the first vector. And this is the journey from B to C. And this vector is defined as go along 2 and climb 1, 2, 3, 4, 5, 6 and climb 6. So the column vector now is 2, 6. But what about our total journey? Well, our total journey can be described as yet another vector, and here it is in orange. Instead of doing two separate journeys, the journey from A to B and then the journey from B to C, we can go straight from A to C. Now, how would that be described? Well, we can count it. 1, 2, 3, 4, 5 along. 1, 2, 3, 4, 5, 6, 7, 8, and 8 up. And there's confirmation of what we've just worked out. The column vector for AC is 5 along and 8 up. Well, where did those numbers come from? From our original two column vectors? Well, you can see, hopefully, that if we just look at the top numbers, 3 plus 2 is equal to 5. Now, if we look at the bottom numbers, 2 plus 6 is equal to 8. So we can add vectors together algebraically by just treating the top numbers as a separate sum from the bottom numbers. This is vector AB, as shown as a column vector. This is vector BC, and this is vector AC. And this fantastic GeoGebra program will enable me to move the points A, B, and C around, and it will keep tabs on what I've done. So if I grab point B and move it anywhere I like, let's do that. There are the three vectors. The first vector, vector AB, is along to climb 7. The next vector, vector BC, is go along 1, 2, 3, 4 and drop 5. Then the resultant here, AC, is the vector 6, 2. Here you see our journey left and our journey right have equated to 0. -5 plus 5, 0. 6 minus 1, 5. So this is vector addition and subtraction.